welcome to another episode of Homework with Ms. Thomas. I am Ms. Thomas, and today we will be exploring Lesson 8 homework of Module 5. The objective is to use area model and multiplication to show the equivalence of two fractions. Let's jump right into it. Okay, so each rectangle represents one. The shaded fractions have been decomposed into smaller units. We're going to express the equivalent fractions on the model and using multiplication. So this first one's done for us. So the difference between these problems and the problems from Lesson 7 is that in the problems from Lesson 7, we started with a unit fraction. So here, the fraction isn't a unit fraction. We have more than one unit. So for this first one, we have 2/3. If you notice here, we have two parts that are shaded out of 3. Here's the third part. I'm going to put that in black. Then they decompose this into 2 rows. So now instead of 2 parts shaded, just make that a little smaller. Now instead of 2 parts shaded, it's 4 parts shaded. Now instead of 3 parts total, it's 6 parts total. We can use multiplication to show that. In order to move from 2 to 4, we did 2 times 2. In order to move from 3 to 6, we did 3 times 2. Notice that we multiplied both the top and the bottom, the numerator and the denominator, by 2. We did the same thing to the top and the bottom. So for the number B, we have 3 shaded out of 4. When we decomposed it, now we have 6 shaded out of 8. The multiplication that happened is 3 times 2, because if you notice, we doubled the rows, right? We did 2 times as many rows. And then for the bottom, we started with 4 parts times 2 is how we have those 8 parts. Let's move on to C. Okay, for C, we have 4 shaded out of 5. So we're going to use multiplication. We started with 4/5. We have 3 rows. So we're doing 3 times as many parts and 3 times as many total parts. So we move from 4 parts shaded to 12 parts shaded, from 5 parts total to 15 parts total. For D, we have 2, 3, 4, 5, 6, 7 parts shaded out of 8. So we started with 7 parts shaded. We have 2 rows. So I'm going to multiply the top and the bottom times 2, which gives us 14 parts shaded out of 16 total parts. For number 2, we're going to now decompose. We need to change this into 12ths. Each of these we need to change into 12 parts and then express it using a number sentence, using multiplication. So for this first one, we have 3 parts shaded out of 6. That long line is for my multiplication. I'm going to change 6 to 12. I'm going to think about what do I need to do to 6 in order to get 12. I'm going to do 6 2 times. So I'm going to make 2 rows. Therein, I'm doing the 3 2 times, which gives us 6 parts shaded. For this next one, I have 2 shaded out of 4 that I need to change into 12 parts. I'm going to think, how do I change 4ths into 12ths? If I do 4 3 times, So I'm going to do 3 rows. Then I will have 12 parts total, which means I will have 2 parts times 3. What you do to the top, you do to the bottom, which gives us 6 parts shaded out of 12. Let's move on. Okay, for number 3, we need to determine if this is true, right? We need to prove that this is true. So we're going to draw area models to prove this number sentence is true. So we have 1/3. I'm going to make that first. So I'm going to make 3 parts, 1 part. If I double the rows, make 2 rows, now I have 2 parts shaded out of 6. So this is true. The multiplication would be 1 times 2 and 3 times 2, which is 2 over 6, or 2/6. For B, we're going to make 5 parts. I'm going to draw 4 lines going down. I'm going to shade 2 parts. I'm going to double the rows, right? So this is 2/5, which is 2 times 2, and 5 times 2, which gives me 4/10. 4 parts shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is true. For C, I'm going to make 7 parts. I'm going to shade 5 parts. I noticed that 7 to 14, that number doubled, so I'm going to make 2 rows. I'm going to double the rows. So I'm doing 5 times 2. I'm also doing 7 times 2, which gives me 10/14. That statement is true. For D, I'm going to make 6 parts, cut it in half, put 3 on each side. I'm going to shade 3 parts. I'm going to do this row of 6. I'm going to triple the rows. I'm going to do them 3 times. So I'm going to break this up into 3 rows, decompose this into 3 rows. I have 3 6. I'm going to do 3 times 3, 6 times 3 to give me 9/18. This statement is true. Let's move on to 4. Okay, here we're going to use multiplication to create an equivalent fraction for each fraction. So no area models here, just multiplication. Let's do 2/3 equals, I'm going to put 2 and 3. I need to multiply them by the same number. Let's multiply them both times 2. That will give us 4/6. For B, we have 5/6. What I do to the top, I do to the bottom. Let's multiply them both times 3. That would give me 15/18. For C, we have 6/5. And you can choose any number to multiply them by, so long as what you multiply the top by, you multiply the bottom by. We could even choose 5. I'm going to multiply top and bottom by 5, which will give me 30/25. For D, we have 10/8. I'm going to multiply top and bottom times 3. That would give me 30 over 24. For number 5, we need to determine which of the following are true number sentences. And for those that are not true, we need to correct those by changing the right-hand side of the number sentence. So we want to change the fraction to the right in order to make it true. So let's see. For this first one, we have 2/3. I need to see if it's equal to 4/9. If I do 2 times 2, I get 4. 3 times 3 gives me 9. So this could not be true because I am multiplying by 2 different numbers. So I'm going to make this a true statement. I'm going to do 2/3. And I'm going to multiply 2 times 3. That would give me 6/9. Now this is a true statement. Now this is good. All right. For B, we have 5/6 equals 10/12. I'm going to do 5 times 2 to get 10 and 6 times 2 to get 12. So this is true. For C, we have 3/5 equals 6/15. I do 3 times 2 to get 6 and 5 times 3 to get 15. So this is false, right? Because these are not equal. And I'm going to even put an X through this equal sign because this is not true. So let's make it true. I'm going to keep the 3/5. I'm changing the fraction on the right side. I do 5 times 3 to get 15. So let's do 3 times 3 to see that it is 9/15. That equals 3/15, not 6. All right. And for D, we have 7/4 equals 21 over 12. I do 7 times 3 to get 21 and 4 times 3 to get 12. So this is correct. This is correct because 7 times 3 equals 21. 4 times 3 equals 12. So I'm multiplying top and bottom by the same thing. All right, that is the homework for Lesson 8 in Module 5. Thanks so much for watching. Hopefully you have a better understanding of equivalent fractions with this lesson. So the next time, keep learning, and I'll catch you on the next one. Bye.